Deadlock and Banker's algorithm. Deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. Let us take two processes P1 and P2 and two resources R1 and R2. The process P1 has acquired the resource R1 and waiting for the resource R2. Process P2 has acquired the resource R2 and waiting for the R1. This is a deadlock situation. The conditions for deadlock are mutual exclusion, no preemption, hold and wait, and circular wait. Mutual exclusion is a condition in which a resource can be accessed by only one process at a time. Hold and wait is a condition in which one process has acquired one resource and waiting for the release of another resource. No preemption is a condition in which a process cannot be preempted for the release of resource. Only the process can voluntarily release the resource. Circular wait is a condition in which two or more processes wait for the resources which are acquired by every process. Banker's algorithm is a resource allocation and a deadlock avoidance algorithm used in operating systems. The primary purpose of Banker's algorithm is to ensure that resource allocation in a multiprocess system occurs in a way that avoids deadlock and ensures system safety. Principles of Banker's algorithm. The system has a finite number of resources such as CPU time, memory, printers, or I/O devices. These resources are categorized into different types and there is a fixed number of each type available in the system. Multiple processes may be running simultaneously, each requiring a set of resources to complete its tasks. Each process must declare its maximum resource needs in advance. Resources are allocated to processes in a way that ensures the system's safety, which means deadlock avoidance. Banker's algorithm checks whether it is safe to allocate resource a process without leading to deadlock.
To create a Banker's algorithm, we initially need four matrices. Three two-dimensional matrices that are maximum demand, allocated resources, and need matrix, and a single dimensional matrix, available resources. Now we can look into the Banker's algorithm, that when a process has requires some resource, the algorithm checks for the available resources, that we can safely provide the resources to the process. If we can, it will safely allocate the resources and get back the resources. If we cannot allocate it safely, the process is forced to wait until the resources are available. Once the process finishes, the given resources and the available resources are being taken back. So the algorithm repeatedly checks the safety conditions while allocating the resource, and when the resources are released from the process, that it is a safe state or not safe state. Why to use Banker's algorithm? Banker's algorithm is used for managing resource allocations in multiple process systems and preventing deadlocks. It ensures that the resources are allocated in a way that resource contentions and deadlock situations between processes for resources are avoided. It promotes the system stability and efficiency by avoiding the deadlocks.